In this video, we'll work some unit conversion problems. In order to work a simple unit conversion problem, we'll need to identify the given units, determine the units needed, and identify a conversion factor or conversion factors that can help us connect between these units. An example problem states, if a person weighs 164 pounds, what is their body mass in kilograms? We first need to analyze the problem and find the given units and the needed units. We see that our given units are in pounds and we need to convert to kilograms. Do we have a conversion factor that can allow us to do that? We need a US to metric conversion factor. We do have one. 1 kilogram is 2.20 pounds. This is an equality. So we can use a fraction to do our conversion. Because 2.20 pounds divided by 1 kilogram would be equal to 1, because this is an equality, when we multiply by that fraction, we haven't changed the essence of our number. So if we start with 164 pounds, and we multiply by the conversion factor, which is an equality, 1 kilogram divided by 2.20 pounds, then we haven't changed the essence of that number. Notice that when we multiply, or when we divide pounds by pounds, we get 1. Pounds divided by pounds is 1, and so we can just cancel that out. 164 divided by 2.20 is 74.5. We don't really need to consider the 1 here, but if you wanted to do it this way, you could think of it as 164 times 1 divided by 2.20. The answer is 74.5, and since our kilograms doesn't cancel out, that becomes the unit in our final answer. Since this conversion factor is a conversion between metric and US units, we'll be limited by the number of significant figures in our measured value, which is 2.20, and it has 3 significant figures. Also, our original number has 3 significant figures, and we're multiplying and dividing, so we're limited by the number of significant figures in each one of the numbers that we're using, and therefore we're limited to 3 significant figures in our final answer. Let's work another problem. A rattlesnake is 2.44 meters long. How many centimeters long is the snake? 2.44 meters, and we need to convert to centimeters. What is the relationship? Well, if you look at your metric conversion chart, you'll see that 100 centimeters is equal to 1 meter. We can use this as a conversion factor. So we're starting with 2.44 meters. Now, we need to use the conversion factor 100 centimeters is equal to 1 meter. Do we put the meter on the top or the bottom? That's right, we need to cancel meters out, so we're going to put 1 meter on the bottom and 100 centimeters on the top. When we divide 100 centimeters by 1 meter, since that's an equality, that's the same thing as multiplying our number by 1. And that's why we can use this as a conversion factor. So our final answer is 244 centimeters, because meters divided by meters is 1, and it cancels out, and we're left with centimeters. 2.44 times 100 divided by 1 is 244. Now let's consider the significant figures. Since we had 3 significant figures in our initial value, we're limited to 3 significant figures in our answer because the 100 centimeters divided by 1 meter is a conversion factor between metric units, and those are defined quantities and don't limit our significant figures in the final answer. Sometimes we may not have one conversion factor that will allow us to convert from our starting quantity to the desired quantity. and therefore we may need to string more than one conversion factor in order to get the correct answer. So in setting up these problems, we follow one factor with the other, and we cancel the preceding unit until the final unit is obtained. Let's work an example. A doctor's order prescribed a dosage of Synthroid of 0.150 milligrams for a patient. If tablets contain 75 micrograms of Synthroid, how many tablets are required to provide the correct prescribed medication dosage? For this problem, we'll need two conversion factors. We're starting with milligrams of Synthroid required. We need to use a metric conversion factor to convert to micrograms, and then the clinical factor, which is how many micrograms are in a tablet, to convert to the number of tablets. Let's see how this is done. We're starting with 0.150, 0.150 milligrams of Synthroid. We know that from our metric conversions that there are 100 micrograms per milligram. And we know that 75 micrograms is in one tablet. So if we work this problem, we see that 0.150 times 100 times 1 divided by 1 divided by 75 gives us a total of 2 tablets required for the dosage. How many minutes are in 1.4 days? We may not have a conversion factor that will allow us to convert directly between days to minutes, but we know that there are 24 hours in one day and 60 minutes in 1 hour. That's an equality at the top. So let's go ahead and work this problem. We want to know how many minutes are in 1.4 days. We're trying to get rid of days, so we'll use the verse conversion factor by putting 1 day on the bottom and 24 hours on the top. Now days cancels and we have hours. Now we can use the next conversion factor. There are 60 minutes in 1 hour. Okay, and so now we can cancel out days, cancel out hours, and we're left with minutes. So in order to put this into your calculator, you'll say 1.4 times 24 times 60 equals divided by 1 divided by 1 again. And that gives us 2,000 minutes. And since we're starting with two significant figures and we're not limited by the significant figures in either of these conversion factors, we need to put this into scientific notation to get two significant figures. And that gives us 2.0 times 10 to the third minutes. If your pace on a treadmill is 65 meters per minute, how many minutes will it take for you to walk a distance of 7.5 kilometers? So we're starting with 7.5 kilometers and we want to convert to minutes. We'll need two conversion factors here. We see from our problem we have a unique conversion factor that we're walking 65 meters per 1 minute. And we also know that there are 1,000 meters per kilometer. So we'll first convert from kilometers to meters and then meters to minutes. So we'll use the conversion factor on the right. 1 kilometer is equal to 1,000 meters. And then the one on the left, 65 meters per 1 minute. All right, so let's get started. We're starting with 7.5 kilometers. We've got 1,000 meters is 1 kilometer, and we're traveling at 65 meters per 1 minute. Now we see that kilometers cancels, meters cancels, and we're left with minutes. So the way we'd put this into the calculator is 7.5 times 1,000 divided by 65. We could ignore the ones because, well, they don't change our number. And so we will walk a distance of 7.5 kilometers in 120 minutes. There's an old concept in toxicology that states the dose makes the poison. In today's science world, we have a measurement for that dose, and it's called the LD50. That's the dose at which the concentration of the substance causes death in 50% of the test animals. A dosage is typically measured in milligrams of drug per kilogram of body mass, or micrograms of drug per kilogram of body mass. The LD50, or the lethal dose that would kill half of the test subjects for caffeine, is 192 milligrams per kilogram. Of course, we don't test that on people. We just assume that we can extrapolate an LD50 to a human population. Here are some LD50s for some common substances. We have table sugar, boric acid, baking soda, DDT, cocaine, and so forth. So you can see that caffeine would be more lethal because it would take less of it to kill you than, for example, codeine or aspirin. Table sugar may be pretty harmless as far as we normally think of it, but it actually does have an LD50. But it takes quite a bit of it to be lethal in test subjects.